Alright, yeah. Okay. Full screen that. Can close this. Close that. Yeah, let me just clean up some tabs. Close that. Close that. Close. 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 Okay, that's much better. Alright. So where was I? Get status. I already have a diff here. Okay. Alright. So we have a refresh. In fact, you know what? Let's just make this refresh a not static. So replace all usages of GameState with this, right? Okay. Status, get diff, TSC stuff. Huh? I guess there was an error. Oh yeah, this, right? Okay, good. Let's just add that. Okay. Alright, so we have like the main thing we did game status yesterday. So then what? Let's look at our well, this is BumperCoins. Let's look at connect 4 for reference. We have a constructor, sure, that's fine. Connect 4, this is connect 4. As you can see in the bottom, like it says cf.ts for connect 4. Like that's just the constructor. So the constructor needs nothing. It just kind of automatically kind of creates everything for us. So but in BumperCoins there is like some what do you call that? Yeah, there's like, so I guess when we call the constructor, it creates like a default it creates a default kind of configuration of cells where they're all just empty. So maybe our constructor should also take 0 things too, maybe. I think that's a good idea. So like we have a game board coins, but let me just like copy that line, but then kind of comment it out, and then just kind of delete everything here. So the wins will be an empty thing. Right. Coins, game board, obstacles, player 1 turn true. Okay, let me just write that, and let me just quit this for now. And a cd into the BumperCoins. Get branch. Because I know like a few years ago, because I've been mostly only working on prod. Like master is fairly outdated, but let me just switch into master. Oh yeah, status. Let me just stash that. Actually, I can just discard it, right? Restore status. Get log. Yeah, as you can see here on master, the it's from 2011. That's the last commit because I basically stopped working on master, only worked on prod. I was doing some like random stuff for yeah, like I was trying. Well, this MCTS is completely wrong because I never actually did that. This is just like kind of a. This was like, or was this MCTS but with different? Wait, what discretization factor? Wait, what? Wait, did I actually do this? Wait, am I redoing work I did 2 years, 3 years? No way. Dense. Okay, so this does sound like I was doing. Interesting. Wait, what? Okay, let me see. Let me see what this is. Let me see. I think it's CD frontend/bot. Because a few years ago, I did do some work on I did do some work on this. Yeah, this is an ancient branch from 2021. Okay, so I can probably copy a lot of these files, but right now I want to build everything from scratch. Like, I mean, I don't want to. I mean, right now I'm just focused on like I'm already doing something like the same way that like C4 was done. Like, just kind of swap it in. But the point is, this is not the file I'm looking for. The file I'm looking for is yeah, less. It's like in shared GameState provider, I think. Like there are see all these like kind of layout functions, like create like kind of like layout 1, 2, 3, 4. So like when you're doing create game state, you randomly sample between like you see a random index, like you just randomly sample between like these 4 layouts, and that's kind of existing BumperCoins code, right? But like so layout 1 to 4 is what it uses, but I think like below is like yeah create simple game state, which is yeah. So this is intended for bot matches. Used for a simple game. Like if you look into the what do you call that? Like BumperCoins. Here, let's just pause it. Wait, no, stop and pause that. So right here, like this layout here, I decided like that's how the bot should be. Like this should be how the bots would be. Now, one annoying thing is how this coin is censored on the line, and we know that like from like a previous like 2 streams ago in discretization, I was talking about like the pseudocode for that. I mentioned how like you want to be in the center of it. So like here there's an ambiguity, you end up rounding here. So like this box would kind of like round here, but this one would round there. So that's a bit off. Maybe just for like, maybe you can kind of keep this here and like this here and that there. So they all kind of start off centered in their square. Just for like, I feel that would be a bit nicer maybe. But anyways, what I'm saying is this configuration that we see at the very start, this configuration is kind of specified by here. So what I'm trying to say is I want to copy this stuff. So first what we do is we create a new game board with a default board width, which is 20, and default board height, which is 15. Again, this stuff, like this branch that I checked out, master, like this I basically stopped working on like 3 years ago in 2021, and I started working on a new branch called prod. And then also there's a replay branch, and there are a few others, but like they've been merged in. In fact, I should delete the replay branch because it's already been merged in. It's a prod. But anyways, right. So, oh wait, yeah. So, Anyway, so let's see what happens. So you create a new game board, and then you return simple layout. Okay. I mean, why do we have two functions? Yeah, I guess I was kind of copying the whole one create game state and then layouts. Anyways, whatever. It seems a bit repetitive. But okay, so in this we have like a new coin at 1.5, 4.5. Okay. So then let's check that. 0 to 1. 1.5 is right here for x coordinate. And 1, 2, 3, 4, 5. So that's this one right here, which is good. And then what's the next one? 4.5, 5.5, 6.5, 7.5, 8.5, 9.5, and 10.5. So it should be 1.5, 10.5 somewhere. Yep, that's this one. 1.5, 10.5, 1.5, 4.5, and this is 1, 7.5. So let's double check that. 0 to 1, then 1, 2, 3, 4, 5, 6, 7, and 7.5. So all I want to do now is shift this x to be like, shift this one to be like kind of fit in this square, that in this square, and then like these both like basically nudge all the coins a bit more to the center. Basically, I want these coins to snap to the nearest, to the next grid cell, next center that they're not into. So this one, the next center is this point, so I want it to snap onto their align centers. That one here, this one here, that one there, and then these like half snap. Like they're almost there onto this one. Okay, clear enough. That's fine. So we're basically kind of like, and then true means that it's a king. That means it has that star. It's the one where like if you destroy it, you win. Destroy opponents, you win. Then so the left coin is a list. Then we have a mirror function, mirror coin list. Let's review what it does. Mirror left coin list. We just kind of create a new coin. So this is the key reflection line, right? Like 20 minus cx. Now this should look really familiar because like connect foreign symmetries, we had like a similar like thing where you kind of like do like the number of columns minus x is x prime, where x prime is like the symmetry thing or something, like the move index, right? Like number of columns minus 1 minus that because of 0 index. Or wait, what? But anyways, that the whole point is that's the reflection right there. So it's basically creating a new coin. And then, what's this boolean here? What? Mirror left coin list. I think that's something to do with rematching. Coin list. Is P1 coins the left side? Wait, no, this is layout 1, sorry. So let's say this is true. So if this is true, that means player 1's coins are on the left. Then we're kind of creating the right coin, so they must be player 2. So this basically kind of like tells us like, it tells us like the is player 1. It tells us like who they belong to. That's the effect of this. And there is some like left and right connotation too. And that typically my convention is P1 starts on the left, P2 on the right. Like right here, P1 on left, P2 on right. I guess that's a result of just like English, right? Like when you read English text, you read from like left to right. Whereas some languages you read from like right to left, and like this is not one of those languages. So I'm kind of used to like player 1 on the the left. So okay, yeah, so just kind of like create a mirror, and then we just kind of like, yeah, push it. So that's self-explanatory. The key thing is 20 minus the x chord. So we just kind of like duplicate them, and then this one is player left is true. Okay, yeah. So okay, so we kind of duplicate it. So now our right coins will be these three right here. So that's good. Maybe try giving human one less coin than bot. Odd. It's left coins. No, this is complete nonsense. No odds. I want it to be fair. In fact, right now it's just A0, Alpha 0. It's just bot versus bot. Okay, so the obstacle is top left corner 5, 6, and then width and height are 2 and 3. So then, like, well, let's just see. So in 0, so like, it's like 5 comma 6, right? Yeah, 5 comma 6 x 5 comma 6. Okay, so then that's 0, 1, 2, 3, 4, 5, and 0, 1, 2, 3, 4, 5, 6. That's top left corner. And then 3 and 2. The width of 2, height of 3. The width of 2, height of 3. Okay, I guess because like X, Y, W, H, but I'm kind of used to the order being swapped, to be honest. But oh, well, I'll take it. Then we mirror that. Mirror left coin, same thing, 20 minus X, right? Oh, we have to adjust for the wind. I mean the width too, right? Yeah, so it's like kind of like similar to like that's for coin is 20 minus that. But then here we have to kind of like consider the width, right? The width of it too. So anyway, so mirror just kind of like guess this one, and we just kind of can like build up our list. We just kind of combine everything, and we return that. Okay, good. So one thing I can do now is a CP shared, or actually no, let's not do that. Let's go back to where we were. And let's just open up the GameState. And so the idea now in constructor is to kind of like, when we're calling GameState, just like we do in Connect 4, the constructor, like when we call it, it creates something pre-initialized to the like the start. Like whereas like prior the commented, we're kind of passing it in. But I basically want this to be like analogous to how the C4 Connect 4 like Connect 4 project, which I live streamed creating it. I want to like kind of just basically like do exactly what that does. And if I kind of do everything exactly the same, then all that's left is just run train.ts for a week or however long, and it should just magically work. That's the dream, right? So okay, let's go down here. So the first thing we need is these mirror functions, right? Mirror left coin obstacles and mirror left coin list. Let's add some padding just to work with. So now we have our left coins. And our right coins is this thing right here. Mirror left coin list. Well, let's actually look at mirror left coin list. Mirror left coin list takes in left coins, and left coins is comes from like left coins comes from wait, no, is P1 left coin? What? The point is that we kind of pass in true into it. So I'm gonna put this in a comment block. Actually, this one is fine. So right coins, add a space there. For each coin and left coins, mirror coin is instead of left coins, let's call this a P1 coins. Like that. And then P2 coins. So then P2 coins, then for each coin of like P1, for each of the P1 coins, what we're gonna do is we're gonna call mirrored. So mirrored, so this one would be false. And we flip it and then kind of do that. Oh, yeah, I was gonna also change the coordinates, right? So C1 instead of 1.5, 4.5 becomes 2. That one will become 2. And this one will become 1.5. And I already talked about that. I want to shift everything a bit closer to the center. Basically, like what I mean is that like from 1.5 became 2.5, right? So like this one, like 1, like 0 to 1, and then 1.5. I'm going to shift it like 1 here. So this one gets kind of 1 there. And like these 4 kind of each get squeezed by 1 unit. And then this one kind of squeezes by, like, shifts to the center by half a unit. So it's like the whole idea is for it to center in the box and preserve this kind of V shape, or this kind of per bracket parentheses, yeah, angular bracket shape. So that's kind of like my idea of like kind of shifting everything a bit. So it's like not exactly what like these bots do, but yeah. But the point is, in 2021, like I was able to like kind of get some bots to work, and like this is kind of the best bot that I got to work. And I already showed this on stream. In fact, actually, why not just, it's only 1 minute, 22 seconds. Let's just like kind of rewatch this. Actually, let me just read this. This is 2 years ago. Wait. Yeah, see? December 9, 2021. Like, basically, like a big chunk of 2021 was like kind of like, at least a few months in 2021, I spent like on and off working on bots. And like I made some progress. I reviewed a bunch of math. It was kind of nice. But like the thing was this kind of minimax. Like this is not in any neural network. This is just hard coded minimax. Like I'll explain. I'll wait, what? Basically like this clip right here is kind of like the best spot I got, and that doesn't use neural networks. So that's why I'm pretty optimistic for this. But anyways, actually let's just read this. This is 2021. And then like, after 2021, after doing this, I kind of lost motivation, and I just kind of like did nothing for a few years in terms of this game. But anyways, like, so I tried and will soon try again my hand at creating bots. Well, famous last words, because I keep saying those again. Are very clear. I mean, I feel like I'm repeating myself a lot. I mean, I am, but like in terms of like this particular message. We'll try again creating bots, kind of hard to apply classical techniques to real-time games with continuous state space and action space, with some abstractions and assumptions like discretization and throttling moves using the energy system. Exactly. This is the mindset that I'm in now, which I wasn't then. And some forced throttling after a move. Wait, what does that mean? Forced throttling after a move. Okay, yeah, because like it's not real time. Like we're basically like, I guess the throttle is for 30 ticks. After a move, we let the game unfold for 30 ticks. I can adopt turn-based ideas to create bots. Many months ago, I was able to create a depth 3 alpha beta pruning minimax bot that's really weak. I manually assign weights to features, coin health. So these are 3 features: coin health, king health, octal distance to enemy king. Here's a demo. And then I'll show this later. Now in the near future, I plan to adapt near future. And like this is the end of 2021. And now it's like mid 2024. So it's like, it's all of 2022 and 2023 and parts like 2.5 years now in the near future. So I guess near future equals 2.5 years. I plan to adopt AlphaGo's MC zeros MCTS policy improvement approach to this game using a convolutional neural network. So I actually tried, like you saw in the commit history, I tried some CNN stuff, but that wasn't like a policy head. That was only a value head, and I found out that that wasn't really doing anything. The point is that to kind of combine like policy and value, like actor critic, like it's like, or like alpha zero, like you need like, I guess like, I know, like in the deep learning course, which I mean, I looked at on YouTube by David Silver or whatever that I talked about in the very beginning of the first video. I think he mentioned somewhere early on that like just value networks alone have bad convergence or something, like they oscillate or something. I don't know, but never mind. But the point is that, anyways, the point is I actually got this to work for Connect 4, which is kind of nice. So now in the near future, as in not near future, like the SpongeBob thing, it's like 20 years later or an eternity later, like cut screen. I plan to adopt AlphaZero's MCTS policy improvement approach to this game using convolutional neural network. First, I'll see if it's even feasible, how long the CNN takes to make a single policy prediction browser. Actually, that's a good point. I should do that again. I think it took like 100 milliseconds for just a value head and not a policy head. But this says policy. I guess like, yeah, it's actually good that I read this stuff. I mean, I will have to do that, but I'm pretty sure like we have like what, like 1 second between move, or like half second between moves or something. 30 ticks. No, what am I saying? No, we have 1 second between moves because the bot like 60 ticks between each move. That's how much it takes to recharge a 0.4 max launch, right? So yeah, that's 1 whole second, or like that's a lot of time. Like that, like yeah, I'm sure browsers can handle that. But anyways, or I can put disclaimer only to like use it on your laptop or not on your mobile. Like only like have the mobile app like not be able to have bots. Only do it. And but the point is, I think the budget's pretty good. Just a question of like how deep can we go? Like just like Connect 4, like you can control the depth parameter, right? Like just like this, right? Like the number of simulations is 10. Like just how you can kind of control it. Maybe you can let them control, because there is a computational budget of like we have like it must take no more than 1 second or 1,000 milliseconds, right? You know, I'm just gonna play this game quickly. Let me try to, nope, it blocked me. I tried a quick cheese. All right, let me just try to win this. Just, I feel like blocking here is not that impressive because like that sets up like this thing, like if you put here, it creates a threat, but that threat for that score already existed. So maybe, I mean, I still feel like this is a useful move in its own right because it prepares that, but no, I want him to put here so I can put on top and create like this double threat right here. So in fact, he cannot put here. So I think just going here is good. Oh, he just lost. Oh wait, no, but this creates a threat too. Okay, that was dumb of me. That's an insignificant move. I'll just control more of the center. I will have to block that, but... So he did not put here because that would have made me win. Wow, imagine if he gets here. That's like connect what? 1, 2, 3, 4, 5, 6, 7. Connect 8. Okay. I cannot put here because that would win, so... Did I just lose? Yeah, I just lost. Dude, I went first and I lost. Anyways, the point is that like, if I make this number like 1,000 or something, and then kind of like, or refresh that and like kind of make it 1,000, then when I go here, right, it's lagging so much. First of all, it's lagging a lot because I'm streaming, but yeah, it took forever to make a move, like here. And like, I'm just waiting and waiting and waiting and waiting. I already clicked it, and it's just like taking forever to make a move. So exactly, the point is that like, you only have like 1 second between moves, so yeah. Okay, what was I talking about? So then CNN feasible, and see how strong policy improvement to the game using convolutional network. I'll see it's infeasible how long the CNN takes to make a single policy move. Because like when you're playing a bot, like it's this real-time game, you can't just wait all day for it. Like in Connect 4, I'm just waiting for it. Like no, there is some budget. And then see how strong a low capacity CNN is in different stages of training. But it's possible I don't have the training time resources to train it. Okay, worst case, I'm not able to make progress in CNN. I can go back to handcrafting features like the alpha beta case, because I already have like this thing kind of working. And then try to replace something similar to AlphaGo Zero or reinforcement learning techniques, but replace the CNN with linear combination of features. So replace training CNN with simple gradient descent. Very simple as gradient with respect to weight of a given feature, simply that feature itself. Yeah, the partial derivative of that is just itself. To train the weights of said handcrafted features. Okay, so let's just watch a game. Like this is like not neural network. This is like kind of handcrafted, just using these like manual weights for these features I assigned in like a depth 3 alpha beta pretraining minimax. So let's just watch this again. Yeah, the bot like kind of comes out of the gate swinging. I should have infiltrated. Oh well, I'm just like kind of not really try harding so much. I don't know what the hell he's doing hitting there. So I'm kind of curling in, pretty passive. I don't like that. I guess I'm just like kind of like making him overextend, the bot overextend, and like kind of okay. Now I'm infiltrating. I'm using this obstacle to like play merry-go-round. I'm attacking his bot, and like he is okay. He finally somewhat making. Well, now he's running away, so I'm just chasing him now. My king's somewhat safe because I can always go around here, and I'm just kind of like I'm chasing his king. He's trying to make a break for it. He's trying to run away. I'm just going to get my king to a bit of safety. Eliminate counterplay. And then he's kind of cornered against the wall. So, yeah. Okay, he's trying to sneak in for some counterplay, but... well, now he just has one king left. And soon after, the game will end. It's pretty satisfying, like, killing a king with a king. So yeah, I mean, it's an okay bot. I mean, not okay. It's like a pretty bad bot, but like, it took me like 1 minute and 20 seconds to win. So like, that's it's pretty bad. Like, it's not fun to play against. It's too easy to beat. Like, one option is just like give me less pieces, some handicap, like create some handicaps. Because right now, like everything is completely fair. Like the rules it's playing with are the same as what I'm playing with. Okay. But anyway, so the main thing, so yeah, that's basically it. So that's why like I did some work in 2021 and like right now I'm kind of like copying like some of the code. Like, I mean, but again, every single line I'm basically like rewriting or like kind of going over. So yeah, it's basically a fresh start in a way. So yeah, instead of left coins, right coins, I'm making this like P1 coins, P2 coins, where the convention is P1 starts off in the left. So P1 coins are there, and then P2 coins, and for each coin in P1, we just kind of mirror it, and that's kind of like that, and then we just kind of push it. Instead of right coins, it should be P2 coins, like that. Okay, so now what do we do? We just kind of like let coins equal instead of left coins, it'll be this, right? P1 coins dot concat it with P2 coins. And then this dot coins equals coins. So that's good. Okay, so let's just do the game board. So this is like do coins constructor loads initial loads a fresh game state with the default start configuration. So basically like whatever configuration here for coins, obstacles, whatever, and no wins, empty win, important. Coins, wins, no wins. 4 bot. Game board. Oh, that's very unimportant, to be honest. Game board. Just like that. Then coins, and then wins, and then obstacles. So we just did this game board nonsense. Because in the past, I wanted like the game board to be like custom, like configurable, like there'll be a default 1520, but like there could be options of like creating your own custom maps where like these options are different. That's kind of why this game board existed. But the physics engine, everything basically settled on that. In the future, maybe like if I'm like kind of making this more multiplayer, like not just 1v1 but like 2v2 or something, or nvn, then like it might make sense to like have an option of like kind of increasing this width a bit. Or like there's like one kind of style of a game where like the board actually shrinks, because like sometimes people can run forever. So what if like the board just kind of keeps getting shrinking in size, right? Like many games kind of have that shrinking thing mechanism. But anyway, so we have a game board, we have some coins, we have the wins, and then we want some obstacles, right? Actually, and then this dot p1 turns true. Yeah, okay, that's good. So obstacles, right? So now let's have some obstacles. So then the left obstacle is that. Fair enough. Just 5, 6, 2, 3. We already went over that. And then the right obstacle is mirror of that one. So then mirror, but left obstacle. Right. Let's copy this whole function. So then, actually this is pretty dumb. Just do a, yeah, let obstacle 2, let O2 equals 2. Sorry about that. Let's just manually do it. It's only one. Like we don't have to like kind of do it for 3, right? We can just manually do it, right? O2 equals new obstacle for O1. O1. Basically, the only thing that differs from like the only difference between these two are just the x coordinates. Like the width and the height, like height 3, width 2, height 3, width 2, that's the same. And like the y coordinates, like distance from the top, is the same for both. The only difference is the x. So like here's the top left, but here's top left. We can't just do 20 minus that because that would give us this, but we have to subtract the width too to get that. That's like kind of why we have that, right? So anyways, the obstacle 20, and then again same thing where we're like we kind of like we have to stick in the 1 a bunch of times, right? Let's add a space here. just like that. Actually, let me refresh my knowledge of obstacles. Like, what is O dot? Yeah. O dot H. Okay, yeah. So the width and the height. X, Y, W, H. Okay, so that's the thing. Okay, fine. Okay, so anyways, where was I? Line 38 or something like this, like right here, or like here I was, right? So O2 is that, and then just let or just do it from here, right? Delete that nonsense. Equals, and then like a new list of O1 and O2, right? Yeah, just like that. Okay, so I think I'm done. I mean, when I say done, I mean I'm done with like kind of adapting the constructor. So like the idea now is that like the constructor should take in. Actually, let me just delete that. Okay, yeah. So constructor loads a fresh game state with default start configuration. So like the coins, basically like at the end of the like first the game board, sure, fair enough. Let's delete these extra gaps. Game board. Oh yeah, actually I'll add a comment. P1 starts first, just like C4. Actually, no, I don't like this just likes nonsense. Okay, yeah, so the game board, just like we have to do it. Remnants of old code, legacy code. Then coins right here, we just load the coins. Then wins, just no wins. Obstacles, just two modest obstacles, like two modest obstacles. And player one starts first. So basically, like this thing at the end for the constructor basically loads something that looks like this, except a little bit of a shift, because I don't want to start in this empty line based on my discretization logic from last time. So okay, right, that's it. Let me just make sure that compiles. Clear. Oh yes. I see. I do see. So basically, like if you look at coin takes fixed point, right? Like less coin.ts. So like these x coordinates are no longer numbers like JavaScript's number type. They're instead a custom fixed point thing, which like when I did the replay system, I basically revamped everything. So okay, let's actually go back to a BumperCoins. Git branch, right? So git checkout prod. Actually, first what I want to do is I want to like kind of go back to a like less shared GameState. This is a GameState provider. The validator is using maps, by the way. So as you can see here, like we're kind of creating the coins like in the like layout one, for example. Like in fact, like these layouts are pretty similar to the existing ones. Like notice how like typically you have like 4 coins, like 1 king and 3 non-kings. But then I basically like chose as 1 king and 2 because like the less entities on the board, like if each coin can move like 8 unit directions or like 4 unit directions, north, south, east, west, then like the number of like the branching factor would be like 3 times 4 or 12. Whereas if there are 4 coins, it'd be 16. Like it's the number of coins times the directions each coin can move. So like if we can reduce the number of coins, then that's like less branching factor. So it's like the neural network's architecture will be like, it'll have less weights, significantly less weights. That's why I kind of want to have less coins. I think 3 versus 3 is a good number. It's minimalistic, yet still like, I hope it strikes a good balance. Like, as you can see here, I had a nice 1 minute, a nice short game, but yeah. Games finish. Actually, I'm not sure if games finish faster or slower if you have more pieces. Because you have more defensive resources, but you have more offensive resources too. Anyways, this looks pretty pleasing to me, nice and minimalistic compared to a traditional BumperCoins game. So anyways, yeah, so the point is that like this is kind of how it looks like with just like passing in raw numbers, like in layout, right? Like layout 1 passes this, but now let's like kind of check out the new branch, right? Let's check out the prod, and then the same less command. Wait, what? Do I not have GameState provider? Yeah, no such file or directory. Like shared. There is no GameState provider. Wait, but then how do we actually like... Wait, get branch. Which branch am I on? I'm on prod. Production. Like, how does game server decide, like... Okay, let me actually look at game server. Oh, so GameState provider is inside game server. I see. So previously in like the master branch, GameState provider was inside shared. But like in the current BumperCoins, because like that's like I kind of like I wanted to like you let front end bot code use it too. But yeah, so GameState provider is like only in the server side. So back to layout 1, right? Let's look at layout 1. Layout 1, you can see I commented out like the old like initially it was like kind of like this, like 1.5, 4.5, but now it becomes like that. Like you see that how it's like fixed point dot from number. So that's kind of like the technique we have to use, right? So okay, cd that. Then but instead of sorry about that. So like this, instead of BumperCoin shared GameState provider, it becomes game server GameState provider. Like that, right? So layouts 1, let's search for that. Oh wait, no, wrong file. Wait, what? What? Wait, what was it searching for last time? Okay. Okay, so like you see how like it says like 1 point, like this is the comment, but then fixed point dot. So let's kind of like look here. Let's kind of start off in coins. So 2.5, 4.5, right? But this 2.5, right? Actually, we just undo everything. Just kind of copy that right here, put a comment there, and then replace this with the fixed point stuff. So instead of 2.5, what we're doing is we're kind of like using that, right? And the 4.5 y coordinate stays the same, so we can just kind of copy that directly, right? Just like that. Okay, so this 2.5, 4.5, that is correct. Now let's do the same thing for here. This is 1.5, so we can just actually copy this directly. And 7.5. Just like that. So let's check. C2, we're kind of like comparing these two. Once they match, I'll delete the comment. So true, fixed point 1.5, correct, that matches with this one. And then fixed point number 7.5, that matches with that one. And true, okay, good. So C2 looks like it's in order. Let's delete it. And C3, let's kind of copy of it, store copy, and then kind of do that. So 2.5 we can just do already, right? Easy. Just like that. And 10.5, right? So 10.5 is a bit different. Just like that. So 2.5, correct, that matches this, and then 10.5, which is matched by this. That looks like it's good. Okay, let's just quit that there. So first we had 9 errors, right? Now we still have errors for obstacle, but let's see how many errors we have now, right? Okay, 6 errors. So now the errors are 20 minus that, right? So that's a bit different. So 20 minus that should be fixed point dot sub, right, for subtract. Actually, let's just like do the errors line by line. Like first the errors were like line 20, 21, 22. Like we fixed these errors. But now it's time, like notice that we fixed these ones too, but like it kind of short circuits and like kind of stops early. Okay, so I think I'm just going to like kind of finish these errors and then call it for now, just the constructor. Like all we've done, my only plan for this stream is just to like get the constructor to work, like create the new initial thing. Pretty modest, I know, but yeah. So, okay, let's just clear this. So then this thing, like we can't like, this is a, like we know that like this thing here has to be a, fixed point in the constructor for coin, but then it's saying its number. So let's look at line 26, right? Let's actually look at that. 26. So this is the thing, right? 20 minus c dot x. So let's see how it's done in the this thing, right? This line, I'll highlight it right here. This thing right here, right? So you mirror the coin in like this current code base. You do fix, actually first thing first, let me just take this thing, line 26, make a copy of it, comment that copy out, just to stash that there for reference. And now let's see how it's being done. 20 minus its x squared, right? I have to write it first. WN, write in the next file. This one right here, right? So we do fixed point dot sub of this whole thing right here. Basically, fixed point dot sub, fixed point dot from number 20, comma c dot x. So 20 minus c dot x, and that's like the new fixed point subtraction. Just like that. So we take this 20 minus c dot x and replace that with this. Does that look correct? So this whole thing right here, replace 20 minus c dot x. So fixed point dot subtract. Subtract takes a and b, where it does a minus b. 20 c dot x. Okay, that looks correct. Okay, let's save that. Actually, let's delete this line because I think pretty sure that's done. And then let's like, so we had 6 errors. Now we should only have, wait, there's 2 errors. Right, because like number, like this is a number, but there's a fixed point. They both have to have the same type. So yeah, now there should be 2 less errors. 26 should be cleared. So she only have 4 errors. Correct, just 4 errors. Okay, next error. Obstacle. Okay, obstacle, 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 obstacle. So whatever we did with coins, we do with obstacles. Same exact thing. So let's just do that. I have to use the restroom soon, so let's get this done quickly. Search for layout 1. It's easy to center it. Obstacles. Five. Oh wait, no, first things first, let's kind of stash that, a copy of that, and then kind of go back to this. So we're taking fixed point dot number 5. So this 5 right here becomes that. Save that. Do the same thing for 6. So you make that a 6. So 5 and 6, then 2 and 3, right? I think we have 2 and 3 already. You can just copy everything, right? So that just copies 2 and 3 over. Just copy the space. So fixed point number 5. Okay, good. 5, and then let's put a space here too. So that's 5. That's 6, comma. That's 2, and that's 3, and then close the obstacle constructor bracket. That looks good. That's 01. Let's just save that. Or actually, no. Before saving it, let me delete this comment. Let me delete this comment line. So like, there's still gonna be errors in this line, but that should be it. Line 35. That's the idea. So 4 errors, there should be like just 2 or 3 errors. Yep, just 3 errors. Only line 35. That's the only kind of offensive one that's left. 35, right? And the only difference here is like the mirroring thing, where like subtracting that's a number, but then like these things are incompatible because they're like they should all be numbers or all be fixed points, so they all have to be fixed points. Same thing we did with coins, except an extra like a nested subtraction. So yeah, just to show that like same mirror stuff. It's like right here, right? Like this function right here. So the way to do that, well, first things first, we copy over this thing. Like this, right? Just copy that, comment it out. So 20 minus o1.x minus o1.w, right? And the rest are the same, which is fair enough. So we're right here, right? This is the part where we do it. Just copy that whole thing over. And let's just do this right here, right? So 20 minus the x minus the w minus the width. This is all being taken care of that. Except now we have to like kind of, so that's like subtract, fixed point dot subtract, like nested subtractions, right? So first we do 20 minus x and this whole thing. So it's like kind of like putting in parentheses, like this minus that and then minus that. So it's crucial to start left from right because like the negative sign distributes across parentheses. Like anyways, simple algebra. So then fixed point dot sub of that, but now O is undefined because it's O1. You just kind of have to stick in the 1 there, right? Same thing there, O1. So 20 minus x and that whole thing minus w, which is consistent with this, right? 20 minus O1.x, which is like this thing right here. Like this whole, like the first sub, like the nested sub does 20 minus O1.x. And that whole thing, subtract from that O1.w. So like from this whole thing, we subtract that. And that's what this, sorry. So what am I saying? No. From this whole thing, 20 minus the x, which is this subtraction right here, this nested one, we subtract O1.w. And that is from this outer fixed point dot sub. I like how like the parentheses, I mean the percentage sign in Vim like lets you kind of like find the matching bracket opening and closing. But anyway, so I think that's correct. So let's just delete that. 20 minus O1.x minus that whole thing minus O1.w. So that's correct. We always undo that. 20 minus x minus w. That's correct. Let me just redo that change. Let me write this file and let me quit everything. So it should be no errors, right? Clear. Okay, good, it's done. Let's just kind of look at the GameState again. .js, just to like kind of see our code being compiled into JS. So yeah, now when we create a GameState, like it's actually showing the like we kind of like we're requiring fixed point, and like and then Browserify is eventually gonna take all these requires and like kind of bundle them up into one JS file. So yeah, so like now we see the constructor kind of work in JavaScript. It's actually doing some work. So yeah, I think that's enough for now. Like right now, all that's done basically is kind of create a default initial kind of starting game state that looks a lot like this, except a little bit of shifts towards the midline to basically have each coin be centered, fully centered and snap to a particular grid cell. X coordinate is like 0.5, the Y coordinate is 0.5, so that like it's fully snapped onto the grid, right? Let me just look at that again. The coordinates are like 2 point. Like see how everything ends in 0.5? That's kind of like the idea. Because you end in 0.5, that means like you're directly in the center of a given cell. And same thing for obstacles. Oh no, obstacles are different because like they're not center points. Like they're defined in terms of like upper, like top left points. Like if you look here, the obstacle, like the X and the Y are not the center. They're rather like the top left. So these have to end in like 0 or just be integers. Like yeah, like 5, 6, 2, and 3, like 0.0. So yeah, okay, and subtracting, yeah, it's fine. So yeah, I think that's good for now. Get status and then just get add all. Get status. Let's just get log. Get commit. Let's call this create or work on GameState constructor to create default initial GameState status. Okay, yeah, that's all. Clear, get log. There's 2 commits, one from Livestream, one from this stream. And I think that's all for now. Later on, again, I'll set up the remote later. So I guess that's all for now. Like later on, we'll have to work on we just have to basically keep copying everything from Connect 4's GameState over to BumperCoins. So yeah, we're just doing that in Connect 4, the constructor kind of create a bunch of empty cells, like a 6x7 grid of empty cells, cell.vacant cell type enum. That's the default for Connect 4 is just one empty, everything's empty. So here, analogously, we create the default, but instead of being empty, there are some pre-initialized coins at particular coordinates. So we just kind of instantiate everything, and that's kind of the completion of we just kind of did the analog for constructors, and then we're gonna have to kind of support every single thing that Connect 4 does in GameState. We have to kind of copy that over. But that's a good start. Just create something, a starting point, some initial kind of GameState to work with. So that's all for now, I guess.